Okay, good morning. Can you all hear me? Okay, so we are going to start from the beginning, but we will be going little bit faster. Actually, I can't say little bit faster. Usually, I go faster. Okay, so that is the way we do it. And also, I'm not going to do a lot of take a lot of time. I'm just going to take 2 hours per week, and that 2 hours we are going to 100% concentrate on our studies. I will just briefly explain how we are going to do it. Okay, just I will take maybe 5 to 10 minutes, then we will move on to the topics. Okay, right. So you are aware that this A level is like your O level, fairly competitive exam. You know that Sri Lanka, the education is highly competitive. At the same time, your syllabus is fairly big. Actually, to be honest, some of the topics that we are going to learn in your A level ICT, they are in the second year in the degree level, because I am mostly doing classes for the degree level for all 3 years, especially those web development, PHP, and some database concepts. Those are supposed to be taught in university, but because of the highly competitive nature in Sri Lanka, not only in ICT, whether it's a maths or chemistry or physics, we have degree level things in your syllabus, which is really bad thing to do. But anyway, that is the reality. Okay, so therefore, quantity wise also is very high, and the exams are also fairly complex or difficult. To be honest, the exams are fairly difficult, so therefore you have to take it in a very systematic way. So this is how we are going to tackle it. Okay, so very upfront, I just want to mention it. So we will be concentrating on the understanding. Our idea is not to memorize. Okay, so you must rely on understand, not on memory. So memory has very little value. Okay, so it has very little value. When you understand things, idea is it will naturally remember. So that is the normal case. If you don't understand and if you try to memorize something that you haven't understood, it's not going to work. Okay, so therefore our key idea is understand the concepts, and also don't worry too much about the exam. The moment the exam comes to your mind, the concept of education goes away. So then you will become stressful. So therefore, don't think too much about the exam. Just enjoy your life. Try to understand the things. Okay, when you understand things, you are happy. When you don't understand things, you are not happy. Okay, so therefore, our main focus is understanding things. Okay, and also when we are doing the studies, conducting the classes, and when you are doing studies, we do few things. One thing is we are concentrating on quality, not the quantity, right? So it is how quality your time you spend on your studies which is going to determine the success, not the quantity. I don't want you to study for 4 hours, 5 hours, 10 hours. I just want you to study 1 hour, maybe quality 1 hour. That is enough. You do whatever you want afterwards. Okay, right? You can do whatever you want. You chat with friends or play computer games or whatever, I don't mind, but spend that quality 1 hour or 2 hour at least per day. Okay, then we are interested in productivity, right? So again, it's related to quality. So when you are spending time, you have to spend time for productive things only. So just because you spend 2 hours or 3 hours, it doesn't matter, right? If you spend something maybe 30 minutes in a very productive manner, that is what manner, but that is what is going to matter. So therefore, concentrate on quality, not the quantity. Concentrate on and see whether are there any better way to do things. If you find that there's a better way to do things, more productive way, let's do it in that way. Okay, the third thing is let's manage things, right? Let's manage things. So there are two ways you can do things: just do it or you manage it. So manage means you have a plan, you have organized things, and also you have to take the leadership, and of course you have to do the controlling. So that is called management. You have to plan out things. You must know where exactly when the exam is, when are you going to finish your syllabus, when are you going to finish past papers, right? You must have a plan. Okay, and when are you going to finish this topic, that topic, and blah blah blah. Okay, and how are we going to do it? right? First we are going to do this, then we are going to do that, likewise. Then you have to organize. Organize means you must have all the resources with you. You must have all the you must have the syllabus with you. I hope you have the syllabus with you, because without syllabus you can't do anything. Then you must have the past papers with the marking schemes, official marking schemes. Then of course you need to have the notes, right? Notes and any other links or whatever that is going to help you your studies. So that is called organizing. So you must know where the resources are, and you must have those resources upfront. Then you have to take the leadership. I am just going to help you. Actually, I am not going to teach you. I am just going to help you, facilitate you. You are the one who is going to take control of your studies, because ultimately it is you who go to the exam. When you are in the exam hall, you are alone. No one is there. It's those who have the leadership will do it properly. Those who don't have the leadership, maybe you have spent a lot of time, but now you are extremely sort of a helpless. So therefore you have to take the leadership. If things are not going the way you want, you have to talk to us, right? And if you like to do things differently, you can talk to us, right? Likewise, you have to do your stuff. You have to initiate things, and of course if the things are not going well according to your plan, and if you feel like no, things are not going well, you have to control things as well. For example, if you feel like this class is not going to work, you don't have to stay in this class, right? So you can say, okay, so this is not going to work, I will do it in a different manner. If that particular website is not good, you have to look for another website, right? Especially you have to refer to those websites when it comes to HTML, PHP, right, Python. You have to refer to internet websites, so that because you have to take your leadership. Okay, so that is upfront. So our concentration is quality, productivity, and manage, and we are not relying on the memory, we are relying on the understanding. Okay, and also when you are studying a subtopic, first look at the big picture, right? Then dig into the topics and see the connections, right? See the connections, and also make sure that you know the practical usages, right? Practical usages, and also very important, ask why. Don't just concentrate on what. Before getting into a particular topic, first ask yourself why this topic is there, what is the importance of this. Okay, so then only you have to go for what. So a lot of students, they are very in a hurry to go into what, then they don't know why, right? They don't know why it is there. Okay, so that is the idea. And also at any time you can ask any questions, right? I don't mind, right? It's actually I prefer if you talk more than me, right? If you talk more than me, that is the ideal scenario. And also if you don't understand a single point, you have to then and there ask, right? Don't wait until the end of the class or after sometimes and ask. No, it's not going to work. Another thing is, I don't know what are the subjects you guys are doing. Maybe some of you are doing commerce, some of you are doing some other topics, right? But whatever the way, ICT is a different subject. So ICT is a formal science subject, formal science. Okay, so formal science includes maths and computer science, right? Maths and computer science. Okay, so the difference between formal science and all the other subjects are, in formal science you can understand something 100%, right? 100%, and these things are not just approximations. If we say 5 plus 2 is 7, it is 7, right? If there's a way to do multiplication, that is the way to do multiplication. There is no other way. That is why two people cannot get the same two different answers when you are doing mathematical problem. It is same in computer science. Okay, it is same in computer science. If when you look at a program, if A says this is the output of the program, the B also has to say the same, as long as they are correct. So therefore, this is formal science. There's nothing called I can understand 50%, I can understand 70%, maybe I have understood something. There's nothing like that. Either you have understood, that means 100% understood, or you have not understood. So there's nothing called. So therefore, you can't settle when I explain something. You can't settle thinking that okay, I have somewhat understood it. No, there's nothing like that. Either you have understood it or you have not understood it. Okay, so if you have understood it, you don't have to worry. If you have not understood it, that means you have to ask questions and clarify it. Okay, right. So let's move on to your syllabus. So I hope you are aware of the syllabus, because now you may have done this for some times now, your studies, right? So you have 13 topics. Out of 13 topics, actually 13th one is not a topic, so therefore we are not going to concentrate on that. There are 12 topics. Out of these 12 topics, there are bigger topics and smaller topics. Okay, the bigger topics are the data communication and networking, system analysis and design, databases, programming, web development. Now you can see that how they have packed it. The small topics, then the big topics, then again small topics. Okay, so therefore we have to spend a lot of time on these topics, and some other topics we can just do it in just 2 or 3 classes we can finish. But of course for these topics we need more time, right? We need more time. Now you can see that 20 blah blah blah, then all of a sudden 60 50 70, now again getting small and small because we are not concentrating on the project. Okay, so that is how it goes. It goes like that and again comes down. Okay, so therefore we are not going to we will be moving little bit faster here. Then you will feel like slow down. Actually we are not slowing down. What we are doing is we are doing bigger topics now. Okay, so then again you will find that all of a sudden we are again going fast. Okay, and then you will find that we are done. Actually I have another class Tuesday evenings. That class we are in the very end now. Right, so today I am going to do the second topic, right? Second topic. So after doing the second topic, we will be moving to the first topic, because the second topic is more interesting topic than the first topic, and also it's a little bit of both technical and conceptual. So this is heavily conceptual topic. So therefore I will first do the introduction to computer, and also I will not be giving any notes. So I told you that we are concentrating on the productivity. I am not going to spend any time for giving notes. The reason is I have shared you the PDF files. So those PDF files are your note, right? Your note. Of course, if you want, after the class, you can go through the PDF file and you can prepare a short note, right? So anyway, so that is how it goes. Your task here is have a dialogue with me. Okay, have a dialogue with me, discussion with me, and clarify things and understand things. If you understand things, you don't have to, you are not relying on the notes as well. Okay, so that is very, very important. Okay, right. So your second topic is introduction to computer, right? Introduction to computer. So I will, at the beginning of the topic, I will just show you what are the things that you are supposed to know, because the examiner, when he prepare the exam, he always refer to the syllabus. So he has the syllabus in the left hand side and he is now preparing the paper, because this is a very competitive exam. They do not, very rarely they set up a question outside your syllabus, because it's unfair, because this is a very competitive exam. You have to do the same thing, right? So you must also always refer to the syllabus and double check, now have I covered this, right? Do I know this particular concept? So then if you know these concepts, now you can assure yourself that now I am ready for the exam. Okay, right. Now I will very quickly go through the syllabus first, the second topic only. Elicit the significance of changes occurred in the computers from generation to generation, with more emphasis on the evolution of the processors, right? So which includes history of computing, generations of computers, different type of classifications or different type of computers. So that is the part 1. Then explore the functionality of the computer in relation to the hardware and their interfaces, right? So that is your second part. The hardware components, we are going to look at the input devices, output devices, storage devices, the processing devices, etc. Okay, so then they explore the von Neumann architecture. So that is in the conceptual level, we try to understand how the data is processed. Okay, so here we look at the hardware side, here we look at it as a sort of a conceptual way. Okay, so more advanced manner. And the 2.4 is examine the PC memory systems and different types of memory and their main characteristics. So it's again hardware, the continuation of the discussion. So then we are done, right? So that is how you are going to do the second topic, right? So always you must have that mindset. So the basic objective of this particular topic is you must know at the end of this topic, you must be able to explain what is this device called computer is doing, right? And you have to explain it in two levels. At hardware level, that is what is a printer, what is a hard disk, what is a motherboard, right? Hardware level. At the same time, in a conceptual level, right? How a instruction is processed in the processor, right? So how the data is represented in the memory. So that kind of conceptual knowledge, right? So you must have the conceptual knowledge. Here it's pretty much your understanding, and bit of things you have to remember as well. What are the type of ROMs, right? What are the generations of computers and stuff like that. Okay, right? So let's move on. At any time, if you feel like if I'm going too fast, just let me know. The idea is I want to make sure that you feel this as a small subject, not as a big subject, right? For example, if I teach this for 4 hours, you will get the feeling that this is a big subject. But if I teach it in 2 hours, you should feel it like it's a small subject. Our idea is to make it smaller to you, not to bigger thing, right? Because now sometimes what happens is you feel like you are like this, and this is my A-level ICT subject. So what we want to make sure is make you big person, make your heart big, and you see A-level ICT as something like this, right? For example, if you show a small ball to ant will say, okay, this is a huge thing. But you know that maybe a rubber ball is not a huge thing, because you are compared to the ball, you are a bigger guy. So the idea is make you big by boosting your confidence, right? Your confidence, your understanding, right? It is not memory. If you try to dump thing to the memory, what happens is you remain the same. You feel like this is getting bigger, right? So that is a wrong way of education, right? What we want is give you the understanding, give you the confidence, so that you feel like this is getting small and small and small, and when the exam is nearing, you must be really confident about yourself. Okay, so you can contribute to this by providing me some answers as well, because it's all about your confidence. I told you, when you go to the exams, when you go to the society, if you become a professional, say you have become a software engineer, so what you bring to your work is your confidence, right? What you brings to your exams is your confidence. It is not your memory, because memory is a really dangerous thing, right? So what happened to some students is, maybe 1 month before the exam, they come and say, my mind is now like a blank sheet, right? That pressure has mounted, and it has blasted, right? Now that person says, now I can't remember anything, my memory is like a blank sheet, because without understanding, they have tried to fill up the memory, right? They don't know why, they don't know the connection, right? So they just feed, dump more and more into their memory. So therefore, so one way to get out of that tragedy is you keep talking, right? You discuss with your friends, discuss with us, right? So then you know that your confidence is there. When I ask a question, if you can answer, that is going to increase your confidence, because you know that yes, I can remember also, right? Not only I have understood, I have remember also, right? So therefore I need a lot of interactions from you guys. Of course, if you don't want, I don't mind, because then I will do my task, right? Because I can't do things on behalf of you. I can do my task, you have to do your task. Okay, right? So let's try to understand what is mean by computer. Okay, right? So computer is, you know that there are different devices. we use in our day-to-day life, in our office work, etc. So computer is another important device, right? Computer is another important device. So we have the washing machines, right? We have the blenders, we have the vehicles, right? We have the blenders, right? So many devices are there, washing machines and blah blah blah. So then we have computer, right? So then our subject is ICT. Students who are doing ICT, our main focus is this particular device and its capabilities. And of course your subject is not IT, your subject is ICT, so information and communication technology. So that means we are not only interested in what is happening inside this computer, we are interested in how they are communicating with each other as well. So that is why your subject is information and communication technology. What is happening inside this and what are the useful things that we can do from here, from these devices, and also how they are going to communicate with each other and what are the usages of that, and we are going to combine both. Okay, right. So let's look at the computer first, because we will be concentrating on the communication later. So what is mean by a computer, right? What is mean by computer and what are the features of computers, right? Special features that you can differentiate from other devices, right? So if someone asks the question, what is a computer? What is the simple answer that you can give? Can anyone talk? Anyone?
Yes, sir.
Yes. What is your answer? If someone asks what is a computer?
So a computer is an electronic device which help us to do, which help us to make our tasks easy.
Okay. So then that answer is okay. That answer is okay, but that answer is not good enough for A-level student. Right? For example, your answer is too general. Too general. Right? For example, if I give you another device, right? Again, you will say it is going to help us make our life easy or whatever. So you have to tell exactly when I ask a question that is for the exam also, you have to give a more specific answer. Can you give a little bit more specific answer? Again, think about what is a computer. Again, think about it. What is a computer? What is the best answer you can give?
So, a computer is an electronic device which transforms data into information.
Yes, so that is the better answer, right? Now the other student must also accept that that answer is more specific, right? So that answer is more specific. So when you go to the exams, you have to give the answer to that particular point, right? So anyway, we are preparing you for the exam also, right? So the computer is it's an electronic device, right? It's an electronic device. So that part was there, right? Electronic device. So don't say to help us do our task or whatever, because every device is for doing that. Your blender is also to doing that. Your washing machine is also to doing that. So therefore that answer is not specific. Now you have to be very specific. So it's an electronic device that help you process data, right? Process data into more useful, right? More useful. Now your statement is now make it more specific, right? More useful information. So that is the better answer, right? So computer is electronic device that we use to process data into more useful information, or just we can say used to process data. Okay, right? So that is a starting point. What is a computer is? Okay, so then someone will ask, why do you want to? Okay, electronic device is okay. There are electronic devices I have seen. Radio is electronic device, television is electronic device, right? So yes, computer is also electronic device. Okay, so you said that it is used to process data into more useful information. Okay, so then someone will ask, why do you want to process data? right? So my question is, I'm again repeating, why do you want to have a computer, or why do you want information more than data, or why we like this more than that? So this is good, but this is better. Why?
So because it gives us accurate information.
Okay, so that is one reason. Can you list down few more features of information over data? It's more accurate, correct? What I ask is, compared to data, what are the now data is also there, information is also there. I have access to data, I have access to information. My question is, what are that? Why you prefer information rather than data? Right? You don't have to say sir, because I told you we are interested in quantity. We are not interested in quantity. I don't want to spend your effort on additional word, right? So you can just give me the answer without saying sir. Okay.
Relevancy.
Yes, this is more relevant. What else? So therefore you like this more than that, because here you get more relevant things. Maybe here you have the non-relevant things as well. Any other points? So this is an example you can take. Forget about the computer. Now think about data as raw rice, right? Information as boiled rice, right? Boiled rice. Now why do we prefer boiled rice or raw rice? Can someone tell me? Few points. So obviously boiled rice is easy to digest.
Eatable.
Yeah, eatable, right? Raw rice is not that eatable, right? And also it's easy to digest, right? Easy to digest, and also it's more tasty, right? So many reasons, right? So no one is going to argue with you about those points, right? Yes, it is easier to digest, it's more pleasant, right? Easy to eat, right? So many reasons are there. So no one is going to challenge you. So likewise, now you have to think about data and information. Okay, can you give me example of a data and relevant information? So that is how you have to think about it. Give me example of a data, and when you process that data, this is a possible information that we can get. Okay, can you give me an example?
So students' marks
Marks
as
is,
data.
yes, marks we will take as data. What is the relevant information?
So the total average.
Okay, average, right? More than total, I think we are interested in average, right? Maybe you are interested in your average. Someone will be interested in the average of the class, students, or entire students. Yes, so this is a data. This is a data, and this is a information. Okay, so I need another example which is not related to marks, or not related to average.
So 1 plus 1 is data.
Okay, information.
2, sir.
Yes, that answer is information. Okay, I will accept that also. Right, I will accept that also. Right. So now you have to think outside these numbers. Right now you are very narrow into numbers. Do you think that the computer is used only to process numbers? No. Right. So therefore, can you give me an example which is nothing to do with the numbers? I need the data. I need the information.
Name of the school.
Okay, now let's now I'm not just concentrating on one topic. I'm going here and there. That is my way of doing, because this is a discussion, right? This is not a whiteboard session. Now tell me, what are the type of data your computer can process? What are the type of data your this now our discussion is try to understand computer. If you don't understand computer, you have no life in ICT. Right? This is our device. So first of all, yes.
Numbers.
Yes, numbers can be processed. What else?
Words.
Okay, we call it text. What else?
Images.
Yes, images. What else? Are there anything else? Sound, audio, anything else?
Videos.
Yes, video. Right, now they are all you will get numbers as data and some information, text as data, information related to that text, image and as a data, and you are giving most of the time if you take image as a data, the output is also going to be image. Audio as a data, audio as a information, video as a data, video as a information. Right, now both the examples that you gave were related to numbers, but computer is capable of doing more than numbers. Now I need example each. Data on the text side, the relevant information. Data from the image side, the relevant information. Data from the audio side, relevant information. Data from the video side, the relevant information. Right. So I need one each. Right. Can anyone give me a possible data which is text, and the after processing, this is the information we get? Have you ever thought about that? Because computer is not only processing numbers, calculator is only processing numbers. Computer is something. Now if I browse my computer, I have video clips, I have images, these are all text document. I am not using this computer for processing numbers, right? So that is the least important for me. I am using this computer, my laptop, maybe 50% I am using this computer for text processing, right? Maybe another 25% video and audio processing, right? Okay, maybe another about 10% for image processing, and maybe just 5% for calculations, number processing. So that means why I have bought this laptop, not to do calculations on numbers. I have bought it for text processing, audio and video processing, image processing. So they have now if you are giving me only these 10% answers, I am not happy with that. I need why I have bought. What is this 50% of task I am doing? What is this 25% of task I am doing? What is this 10% of task I am doing? Of course, in your case, it will be different.
So if we type a country name, then we can get the population location as the information.
How do you get, by entering a country, how do you get the population? Now forget about the systems, right? Forget about the system. What I need is forget about that kind of system. What I need is what kind of things you do to get that. That is not a text processing actually. That is a different information system is there, right? Right. So I will give you a very simple example. Now I have prepared this PDF file. Right? So this is I hope this is in a very nice format. Right? This is in a nice format so that you can understand, right? Which include few images as well. Now this is how I am going to prepare this. I have my Microsoft Word, right? I take my Microsoft Word. Right? Then I type these things. So sometimes I copy paste these things from other notes, etc. Right? Then I am keep on preparing this, right? I will say, okay, this is my heading 1, right? And this is my heading 2, right? Then I will be having a paragraph. Then I will be having a table, right? So now what I am doing? What I am typing is my data. But what I am not just typing. If I type those things in a notepad, still the data is in the raw format. Right? Still the data is in the raw format. It's not it has not added much value to that, right? But I am not sharing you a notepad or the text document. What I am sharing you is a PDF. That's PDF. I have done some bullets. bold, italics, right? So important points are highlighted, paragraph things, right? Sub bullets. Now this is the information. Now this is the information and this is the data. Right? Same thing, if I type it in the notepad, that is data. But if I put it into something like this using a word processing software, that is your information. Now, which one you prefer? Do you like me to share this kind of document with you, or do you like to have this kind of PDF file? So obviously you prefer this one. So this is data processing. So your mindset must not just concentrate on numbers, because I told you why I have bought this laptop. My 50% of my task is this, right? So lot of times, right, why you buy a smartphone? Do you think that now smartphone is a computer, right? It's a small scale computer. So do you buy a smartphone to do calculations, to calculate average or things like that? No, most of the time you are chatting with others, sending an email, right? Viewing a website. It's all text, right? It's all text, right? So they have the web developers has written those HTML files, right? CSS files. Now you are seeing it, the information. Now you can see that if you go to a website, now this is sort of a data, right? This is sort of a data inside, right? Which is processed by the browser, and now you see it as a nice nicely formatted things that which you prefer, right? Which you prefer, right? So this is the output, this is the information, right? So therefore now you can see that we heavily use computers to process data, text, right? So do we use computer to process images? Of course, yes. Say you take a picture, you take a photo in your smartphone. Now you have two options. Anyway, when you are taking the photo also, it is somewhat processed. Now again, if you want, you can just upload it to your Instagram or whatever, or you can go to a word processor, image processor like Photoshop or whatever. You can add some effects, beautify it, right? Modify the color imbalance. So then you are, so why you are doing that? Because you want the processed image you like more than the unprocessed image. So that is also data processing, right? So for example, when I talk, right, when I talk, yes, so when I talk, my voice is processed in this computer and it is sent to you. It is sent to you. Sometimes if there are background noise, etc., sometimes you don't hear it, because we have the filters and other things in the Zoom also. So that is processed, and processed data is sent to you, right? So that is because that is better rather than sending the my voice as it is. It removes all the background noises and any other. For example, even the computer has a fan is also giving noises. Even we have that cancellation is also there. So now you can see that we are processing numbers, we are processing text, we are processing images, and also we are processing audio and video, right? For example, if I upload a video to the YouTube, it takes at least 20-30 minutes to process it. After processing only, it is going to publish into the YouTube is going to publish your video, because it is doing some optimization, because people have the concern about their excessive data usages. They are trying to optimize it. So it's again process, right? Because it is better, right? It is better, right? Right. So now I hope you have a very good idea, very broad idea, not a very narrow idea about what is computer is. Computer can process numbers. That is the least thing we do most of the time, right? In our day-to-day life, this is the least usage. The biggest usages are the text processing, image processing, audio processing, and video processing. So therefore, don't just narrow it to this, right? So this device is much more versatile device. So don't just give answers only in this area, because this is the least use. Okay. Of course, if it is a banking system and things something like that, if it is supermarket, of course they are the most widely usage is this, because they are calculating the bill, they are calculating the balances. But day-to-day life, we use more than this. We use our computers for these things, right? Text processing, image processing, audio processing, video processing. Now you must be able to give examples in all these areas, right? So the raw text, your word processed document. The raw image, the image after beautifying and all those effects. The raw audio after reducing all the noises and enhancing your, and sometimes we have to mix audio with the music and those things. So that is your final thing, right? What you hear as a song is the information, right? What you hear as a song is information, because mostly now the songs are processed using digital audio formatting, but they were sometimes separated, recorded. Voice is separated, recorded. Instruments are separated, recorded. They have added some special effects. The final information is the song, right? The song is the information. Okay. So similarly, your film or the documentary is the information, the process one, whereas when they record it, what they have is the raw things. Those raw things are processed in the video editors by professionals, and what you get is the documentary or the film or whatever. Now, so therefore, be very don't be narrow into small things, right? So look at the big picture, right? This is advanced level, so we expect you to be more matured, right? More matured than ordinary level. Okay, right? So now I hope you know what is a computer's main task. The computer is capable of processing your raw data into information that can be a numbers, text, images, audio or video, right? Audio or video. Now you should be able to give examples for each, right? That is what I have been doing, right? So that is what the computer is doing. And then now you know why we like this information. We like the song more than these raw audios, because the song is more pleasurable to listen. Why we prefer to watch the movie rather than these individual scenes, etc., because it's more pleasurable. Why you like that PDF rather than those raw text, right? So you have to think about those also. Don't just narrow it to marks and average. So everyone knows that, right? So everyone in the world knows marks and average. So you have to think little bit beyond, right? So you have to think little bit beyond, because everyone is trying to force you into a small box, right? So you have to get out of that box and see that the world is much more, right, enjoyable. Much more things are there in the world. So sometimes what happens is you are forced to, right, think inside the box. So therefore your life is the marks and average. There's no life beyond marks and average. But if you look at the world, people are using these computers for so many other things. Why don't you want to learn about those things? Okay, right? So that is now you know what are the type of things that the computer can input, and they can give you information in different formats as well. Okay, right? So we were originally discussing about why we prefer information, okay, over the data. Now you know that the information is usually easier to understand, it is more relevant, right? And it is more accurate, right? All those things are there. Informations are good for the decision making, right? Because people are looking at your Z scores more than the marks, right? Because for example, when they select students for the universities, they don't look at your marks, they look at your Z score, right? Because that is where the informations are used for decision making, not the raw data, right? Not the raw data. Okay, right? So I hope you have understanding about that, the difference between data and information. Okay, right? So now you know that the computer can process different type of data, right? Numbers, text, images, audio, video, etc. Okay, right. So now my next question is, how does the computer convert this data into information? Because these are the questions. Now you must be having answers, right, if you are doing ICT. So my question is, how does your computer convert the marks into Z scores? How does computer convert that raw text that I type into nice PDF document? How does computer convert a raw image into a really nice, beautified, pleasant for image? How does computer help converting those recordings into a nice song? How does computer convert those sceneries and those things into a really pleasurable movie? Right? How does computer do that? Do you have answer? Because you are doing ICT, right? You are doing ICT, right? So because computers are used for those things, right? Those things. So how does computer do it? If you don't have that answer yet, don't say that you have learned ICT. Maybe you have learned something else, right? How does computer do it? Do you have at least some sort of answer? How? Any answer?
Sir, by the processor.
By the processor. Okay. What does processor do? How does processor convert your data into information?
Excuse me, sir.
Sorry?
Sir, the computer process data in 3 stages. First of all, input and process and output.
Okay, my question is, how does computer process it? What is mean by processing? That is what you are supposed to know as ICT student. What is mean by processing? So when we say the computer is processing your data into information, my question is, what does the computer do? Do you think that my question is unfair question? Do you think? As ICT student? Yes. So if not, you must have some sort of a reason. No, okay, I will ask different question. Right? Say I will assume that say you are not ICT students. Right? You are not ICT students. You come to a class, you come to a course so that you want to start a laundry. And this is not to insult you, right? This is just a typical scenario I always take, right? So at the end of the course, you want to start a laundry, right? So then you know that in the laundry process, we have the dirty clothes. Then what your customer need is clean cloth, right? Clean cloth. We have the dirty cloth. What they want back is the clean cloth. Now we have to process it, right? We have to process it. Once you process it, the output must be clean cloth. Now my question is, how do you process it? How do you convert it to clean cloth? Which process will convert it to clean cloth?
Washing, sir.
Yes, washing. Right. So my next question is, what is mean by washing? So that is same as what is mean by processing data. What is mean by washing? If you can answer this question, then think about the same thing about this. First answer this question, what is mean by washing? What is the idea behind washing?
Cleaning the clothes.
Oh, okay. What is the idea behind cleaning? How are we going to clean it? Can you explain it? The cleaning process, the mechanism, idea.
We soak the clothes with water and we add some detergent and we wash it, sir.
Okay, why do you want to soak it and do that? What is the idea behind that? Or what is the mechanism behind that? Still, you didn't get my question.
So it's the way of cleaning it.
Okay, what is that idea behind that? thing? Why do you want to put it into the water? Why do you want to add those soap or whatever? That is my question. What is the idea? What is the okay? Why you are adding water? Why you are adding this soap? That is my question. What is the reason behind that?
To get a clean cloth, we should
Yes,
do all
I know,
this.
to get a clean clothes. Okay, right. My question is, what is the mechanism behind this task? So that is the seriousness I expect you from you. I just try to make you a serious person. If I tell you the answer, you will feel like ashamed, right? Shit, I should have told that answer. So you will feel like that. So that is why I am giving you the opportunity, because this guy is asking a very simple question. So you will feel really upset about yourself if I give you the answer. That is why I'm trying to get the answer from you guys, because I am not asking advanced question. I am asking a very simple question. Now, why we want to soak it in the water and put some detergents, and what is the reason? If someone asks, why do you want to put it into water? Why do you want to then add soap? Can't we just put it into water and take it back? Can't we just put it into sand rather than water? So those are the questions that you must ask. Can't we put it into oil and take it back? What is the idea behind this whole business of washing? So that is the processing. It process into clean cloth. So shall I tell you the answer, or you want to give it a try again? Right. So what is meant by dirty cloth? Dirty cloth means your cloth has dirt, right? Dirt, some particles, right? Some particles, dust, and those things, right? The idea is, first, now you want to somehow separate that dirt from the cloth. That is the idea, right? Separate that dirt from the cloth, so that now your cloth does not contain that dirt particles. Okay, so how are we going to do it? First, because we can't find those tiny particles one by one and eliminate it, right? Because they are so tiny. So we are going to use a mechanism. We put it into water. Then when you put it into water, there's a tendency that those dirt particles will dissolve in the water. Now the dirt particle is no longer in the your fabric. It is in the water now. Then when we drain it, with the water, the dirt particles goes. Now your cloth is not having, or having lesser dirt. Now that is the idea behind washing. Right? So do you think that my question is very difficult? No, my question is extremely simple. So then someone will ask, now you have to ask, then why we are adding soap? Now at least for that, do you have answer? Have you ever thought about why we are adding soap? Or you are just adding soap for the sake of others adding also? Why we are adding soap?
It is more useful.
It is more
useful for us to take away the data.
Again, your answer is more useful. If I ask 1 million questions, your answer is more useful. So that is not good enough. So when I ask a question, I expect a specific answer, right? So otherwise, if you give that answer 1 million times, no one is going to accept that. So that means now there are things that can happen to the people. Now people have questions. People have questions. So they are uncomfortable when they have questions, right? They are uncomfortable when they have questions. So therefore, they like to have answers. Right? They like to have answers, because when we have questions, we are uncomfortable. So some people, they try to find the exact answer, because when we have questions, we are uncomfortable. Some people, they just want to get rid of this uncomfortableness. So therefore they find some answer, not the exact answer, not the correct answer. Then they are not uncomfortable because they feel like, no, now I got the answer. But that answer is for every question the same answer. So how can every question has the same answer? Because it's useful, because it's useful, because it's useful. No. So now that is, you are sort of cheating yourself. So we have to be serious. So let's not just take the same answer or some answer. Let's again ask, is it that real answer? Right? So now I am again asking the question, right? Why we are adding soap? Again, I don't need very serious answer, but don't give me that the one and only answer of the useful.
So to get a good fragrance.
Okay, that may be one reason, but use of soap is the getting the fragrance is not the main purpose of soap. I think you accept that. Okay, then we should have had some sense. Of course, there are some with so after doing your washing, there are some other things also. If you want, you can add it just to give it a fragrance. Therefore, so the main purpose of soap is not the fragrance. That you have to accept. Do you agree with me?
Yes, sir.
Yes. So you have to accept it, right? So therefore, again, you have to think again now, because still you are in trouble. I'm just pushing you. I'm just pushing you to think. That is my task. Somehow, if your thinking start, I can stop my work. Right? I can just share my PDF. You are going to start learning by yourself. But your thinking has to be started. Why we are adding soap? Now you have been doing science for grades 6, 7, 8, 9, 10, etc. Have you ever asked from your science teacher why we are adding soap? So those are the questions that you should have asked. Okay, right. So the simple reason is, when you add soap or whatever that powders or whatever, it helps taking that dirt out of the cloth, right? Because yes, those dirt particles are dissolved in water, but they are better dissolved in the soap water, right? So there's a chemical and physical phenomena behind that, right? So they better dissolve in the soap water than normal water, and also that soap give you some sort of a lubrication effect. So when you are washing, what we do the next, we soak it, then we apply some forces, frictional forces, right? Whether you are doing it manually or whether you are doing it using the washing machine, we apply some forces. Why we are applying those forces? Due to that friction, those dirt particles which are more tightly bound are also going to be removed. But in order to remove that, when we have that lubricant effect, it is easy, and also those chemicals are going to take that dirt particles out easier than just water. If you have just water and do that mechanical forces, it might remove, but you have to give more effort. But that chemical nature of the soap help you that lubricant effect, as well as the dirt particle tend to dissolve more in the soap. So therefore, when you add soap or whatever the detergent powder, it make your washing task more productive. You can get that output with less effort. So that is why we do washing. And now you know how the dirty, now washing machine is a device which convert dirty cloth into clean cloth, and you know how the things are done, how the dirt particles are removed, and now you are getting the fresh cloth again, right? So now your task is not to start a laundry, right? So your task is learn how the computer works. So now think about that same seriousness you have to apply. So here also you need seriousness to understand what is washing is. Now apply the same seriousness and tell me, how does computer convert your raw data into process or more useful data? How does computer convert your marks into Z score? How does computer convert your this kind of a text that you are typing into this kind of a nice formatted document? What is the idea behind that? If because that is what you are supposed to know at the end of that topic, not at the end of the ICT, A-level ICT, at the end of the introduction to computer topic, right? We have an answer, a valid answer, not just an answer, valid answer. Because you are not going to learn you are not in the laundry course in the A-level, you are in the ICT course. Can anyone tell me the answer? How does computer convert your raw data into more meaningful data? How does computer convert the picture that you just took it into really nice beautified picture? How does computer convert these different audio track into a nice song? Of course, with the help of the human skills as well, but we are going to use the softwares. How does those softwares do this magic? It is not a magic. Do you have an answer for that? Yes?
By removing the unwanted data.
By removing the unwanted things. Okay? How? Which process is doing that? Now here, what is the process? Soaking and applying some mechanical forces. That is why even a washing machine, you will see that noises and other things, right? Soaking, apply mechanical forces. Is it going to apply mechanical forces to these data? Is it going to soak this data? Is it going to soak your numbers? Is it going to apply some mechanical forces on this, hammering these numbers? No, right? So what kind of things your computer is doing? That is what you are supposed to know at the end of the topic 2. If you don't know at the end of the topic 2, the objectives are fail. You had
So the computer.
Yes.
So it processes the data in a way that it is completed and has an accurate information with to the relevant data.
Now again, my question is what? What is my question? How it does, not the properties of the output. Right. So now my question is, my question was not what are the properties of this clean cloth. What I ask is, then you can see, okay, it's more clean, it's very pleasant, right? But my question was, how does this is converted to this? So then you have to explain this. So when I asked how, you can't give me this answer because my question is here. Now my question is, how does your 5 plus 5 become 10? How does your marks are converted to average? How does your raw picture becomes much more beautified picture? How does your recorded audio becomes a really nice TikTok video with lot of efforts and so background effort and so many things? That is my question. Because that is the objective of what is computer, introduction to computer subject. How does it work? Yes, my question is how? Internally, what happens to these things? Now you know that
by producing instruction.
By processing? Okay.
So it has certain tools which will analyze the data and
Okay, what are those
convert
tools?
it into-
What are those tools? Okay, now tell me. Now computer has different parts, right? Which part of the computer is doing the processing? Are you very sure about that?
the
Which
central processing.
central processing unit? Okay, CPU. Right. In the CPU, what device is doing that processing?
Processor, sir.
Processor. Okay, or if you are very precise, we call it what? What are the components of a CPU?
The control unit,
Okay, control unit,
ALU,
ALU,
memory registers.
okay, registries. Now out of these three, which component is really doing that processing of your data into information? Is it all three, or which one is the real guy behind the processing? The major
So
component, ALU, right? So the major component that doing this processing is converting your raw text into word processor, word document, converting your raw image into that beautified image, converting your audio into a song, converting your different recordings into a movie. It is the processing is done by the ALU. Others have to help that. Okay, right. What does ALU do?
So it performs mathematical and logical calculations.
Okay, what is mean by mathematical? Which is better? You like the word mathematical, or there's a better word? What is a better word? Mathematical and logical. Rather than saying mathematical and logical, there's a better word for that. Logical, I take. I don't like the word mathematical. There's a better word. What is that? Sorry?
Arithmetic.
Arithmetic. So then you must know what is the difference between arithmetic and mathematics. Is it the same? Is it the two different? Can anyone tell me? Is it the same or is it different? Mathematics, arithmetic.
It has a difference.
What is the difference? Now your answers have that idea. It's something like this. Now you are like a gem, but raw gems. But the raw gem is not that worth. But if we can cut and polish it, your answers so precisely, now it is going to shine. But still it's not shining, right? Still it's not shining. So I'm trying to make it shining. Okay, make it shining. Right. So that is why you are using the word mathematical. So you are not very serious. You are here and there. So what is the difference between mathematics and arithmetic? So mathematics is that big subject, right? So mathematics has different sub areas. Arithmetic is one area related to numbers. Then you have the algebra. Then you have the geometry, right? Then you have the set theory, right? So you have the statistic, probability. So that is the maths, right? So there you have one area called arithmetic, which is all about numbers, right? Addition, subtraction, multiplication, division, different type of numbers. Okay, so that is your arithmetic subject. So your computer is not going to do geometrical things. It is not going to do anything else. Of course, these subjects are also related to arithmetic. Okay, but arithmetic means it's all about number related things. It's nothing to do with the Pythagoras theorem or whatever, right? So we don't have that kind of things. Okay, right? So here it's arithmetic. Arithmetic means related to numbers and calculations. Okay, so now you can see that it is doing arithmetic things, it is doing logical things. So your data is something like this, and it applies some arithmetic and logical things, and it becomes something like this, right? Something like this. How does, right? Now that is now you must know that you must have to accept that that is a little bit better answer. But how does computer convert your data into information? By applying arithmetic and logical operations. Now do you agree with that answer? How does your washing machine convert your dirty cloth into the clean cloth by doing the soaking and applying some frictional forces. How does computer convert your data into information? It is not by doing soaking or applying some mechanical forces. It is by doing some arithmetic and logic operations, right? Arithmetic and logic operations. So that must be your answer. When I ask how does computer process your data into information, your answer must be by applying arithmetic and logic operation. Any other things? No. Is it going to heat it? No. Is it going to soak it? No. Is it going to apply some mechanical forces? No. It is going to apply some arithmetic operations, logic operations, nothing else. Okay, nothing else. Okay, so that must be your confidence. Right, that must be your confidence. Right, now when I ask questions, you give answers. Okay, that is good. What is the next level? If you can achieve, you must start defending your answers. You must start arguing with others. No, my answer is the correct one. So, but you can't argue with others, defend your answers if you are not very sure about your answers, and if your answers are not that good. So that is the level that we expect from you, right? So you are very sure about your answers, and even you can defend your answers, right? So try to come to that level before going to the A-level exam. So then only you know that when you get out of the exam hall, I must be having A. Otherwise, I am going to kill that examiner because I am very sure about my answers. So that is why some students go for recorrection, right? So they are very sure that they must get A, but they have not got A. Maybe they are very sure that this must be something wrong with the marking process. Maybe someone else marks has given to me. So that is why they ask for recorrection, right? So sometimes it works, right? So you must also have that kind of a confidence with you, okay? Right. So now you know that how does computer process your data into information, whether audio or video or text or numbers, by applying arithmetic and logical operations, right? That's it, right? That's it. No, nothing else. If something else is also done, they will call it arithmetic and logical and that X processor, right? Arithmetic, logical and heating unit. Right, arithmetic, logical and mechanical unit. No, it is arithmetic and logical unit. That means it's going to apply only arithmetic operations and logic operations. Okay, so then someone will ask, how do you apply arithmetic operations to an image? Okay, so they will say, okay, I can understand. You apply arithmetic operation to the marks. You apply arithmetic operation to the quantities that prepare in the bill in the supermarket. But how comes computer apply arithmetic operation to my image? How does computer apply arithmetic operation to my sound? Do you have an answer for that? Now you have to think. You have to argue with yourself. Do I have answers for these questions? Or I am just blindly reading some text and just memorizing. I hope these are all valid questions, right? As a human being. How does computer apply arithmetic operation to my audio, my video, my image, my text? What is the answer? Do you have an answer?
So because those are converted to binary languages?
Yes, not binary. Yeah, so that is okay. Let's forget about the binary language. Yeah, it's converted to binary numbers. So that is the perfect answer. So now whenever you are giving me answers, sometimes I argue with you, right? So, but I am not going to argue with that answer because I am going to be in trouble if I try to argue with that answer. Right? So that is the kind of answers I expect more and more in the future, right? Because everything is represented as binary numbers. whether it is numbers or text or audio or video or image, computer convert everything into numbers. So if it is a number, why can't we apply arithmetic operations? Because numbers can be added, numbers can be subtracted, right? So therefore that answer, no one is going to argue with you. Yes, if they are represented as numbers, computer must be able to apply arithmetic operations, right? So then they will ask, how does computer then apply if it is binary numbers? If it is a binary number, your text is, your audio is, your video is, your image is a binary number, set of ones and zeros. Okay, then the person will say, okay, I can accept that you can apply arithmetic operation. What are the arithmetic operation? Addition, subtraction, multiplication, division, those are. Then he will ask, okay, how do we apply logic operator? How do you apply logic operator? 1 and 0. Do you know that there's a logic operation about ones and zeros? Now what is your answer? What is the purpose of having logic unit? Because that is your processing unit. Can you apply logic operations to the these numbers? Say 1 0 0 1 and 0 1 1 1 0, something like that. Can we do that? Yes or no?
Yes, sir.
Yes, we can. So that is really good. That is the confidence I need. You have to say, yes, we can. Right? So then other person will ask, okay, now you are saying that you can apply logic operation to this. Okay. Now can someone tell me, if I do something like this and I want to do AND, what is the answer? What is the answer? You just have to take a piece of paper, or just by looking at this 1 0
1 0 1 0 1.
Yes, the answer is 1 0 1 0 1, because when both are 1, only 1, otherwise 0. So therefore now you can see that yes, the movement to represent your data, whether it's audio, video, whatever, as set of numbers, binary digits, you can apply by arithmetic operations, you can apply logic operations. So that is why you have a topic called, right? Now I'm just giving you the big picture of your syllabus. That is why you have a topic called data representation. So data representation means what? How to represent data in the computer. So that is your topic 3, right? So now I'm gradually giving you the overview of the subject, right? Right. So that is, yes, in the computer we represent everything as binary numbers and we process it using arithmetic operations and logic operations. Of course, binary numbers can be applied with arithmetic operations and logic operations, right? So then someone will ask, okay, I accept that also now. So you have convinced me that once the everything is represented as set of ones and zeros, you can apply arithmetic and logic operations. That now I'm pretty sure, because you showed me that you can do AND operation, and of course you can show you that this is how we are going to add these two numbers. Say how to add these two numbers. 1 plus 0 is 1, 1 plus 1 is 2, 2 means 0, giving 1, 1 0 0 is 1, 1 1 is 2, 2 means 0, giving 1, and this is 1. Yes, yes, you can do add operation, you can do subtract operation. Those are things that you learn in your that topic, representing the data, right? Right. So now you told me that computer is converting data into information. When I asked how, you told me that by applying arithmetic and logic operations. Then I asked, how can you apply arithmetic and logic operation to my image? Then they told you that everything is first converted into binary. Then I accept that also. Then my question is, how are you going to apply arithmetic operations in your ALU, right? How are you going to apply logic operations in your ALU? How are you going to do this O operation? How are you going to do this AND operation? How are you going to do this subtract operation, right? How are you going to do these operations? Because there must be a way. There, right? How does computer do these arithmetic operations and logic operations? Now we have gradually come into the understanding.
So because these binary numbers represent the actual numbers.
Again, look, listen to my question. My question is how. When I say how, you have to explain a mechanism. This is how it is done. Sometimes I ask how, sometimes I ask why, right? Sometimes I ask what. Most of the time you assume that what I'm asking is what. I very rarely ask the question what. I ask why, then I ask how. So my question is, how does computer do this? Computer does this AND operation, this add operation, because you told me that the computer is converting your binary numbers to information, data into information by converting that binaries representing data into binaries representing information. Then you told that these are the operations, arithmetic and logic operations. My question is, how does computer do these arithmetic operations in binary level? How does computer do these uh, logic operations in your processor? Just one word is going to convince me. And this answer you must know by now.
So by using the ALU.
Okay, I know that by using the ALU. Inside the ALU, how does computer do this AND operation? This AND operation, this AND operation. How? My question is how, not what. Or maybe I need little bit more information. At low level, how does this 1 plus 1 is taken as 0? This 1 and 0 is maybe O0 is taken as 1. Which, which device does this at low level? At high level, I know it is done by processor. If you go to little bit more lower level, I know it is done by ALU. If you keep on looking at this, now this is now what we are doing right now is something like this. Now first we found that this data is processed by computer, right? This data is processed by computer. Then we dig into that computer, and we found that of course it is done by, when we say processing is done by computer, it is actually done by your CPU or the processor. Then when we dig into that, we found that when we say it is done by CPU, actually it is done by your ALU, right? So now you have to dig into that further, and you have to tell me what is this, how does these AND operations or operations are done by which device in your ALU? How do you call that device? It is something like, now you look at a human, then you see that the humans has different organs, stomach, heart, brain. But if you further dig it down, you will see there are cells, right? Cells, right? So likewise, if you go to the cell level, if just like we go to the cell level in the human body, human organ, what is that device in ALU that is going to do this processing? How do you call it?
Machine language.
No, it's a hardware thing. Now, if you look at this very closely, the answer must come to your mind. Now, you can look at this 1011 0101. Say, I want to do an AND operation. AND operation. 1 and 1 is 1. 1 and 0 is 0. 1 and 1 is 1. 0 and 0 is 0. 1 and 0 is 0. Right, so that is what happens at the bit level, right? So we have a set of bits, and there's AND operation happening, and now you told you that it can do the AND operation, and yes, after the AND operation you get this. My question is, which device inside your ALU is doing these conversions? 1.1 becomes 1, 1 and 0 becomes 0. How do you call that device? Because it has to happen, right? There's nothing called magic in your computer. It's something that the engineers have built it. Engineers are just like you and me. Of course, I am engineer by profession. Therefore, I am more interested about that. So engineers are the people who are building this. It is not coming from outside the world or supernatural power. No, engineers spend their brain power and they do it. Now my question is, which device inside your ALU is doing this 1 and 1 is 1, 1 and 0 is 0, 1 and 1 is 1, 0 and 0 is 0. Which device is doing that?
So is it the memory unit?
No, memory is not going to do any processing. Memory, that is why I told you, in your studies also, don't rely on memory. You rely on understanding. So memory is just going to remember things. Understanding is where you process things. So therefore, memory is not going to do any processing. Memory is just, if for a memory cell, if I say 10 10 10, it is going to keep it forever as long as we have not overwritten it. So it's memory is just dumb cell. My question is, which device is doing these AND operations, O operations and stuff like that? Not the control unit. Now you have to look at into the more and more tiny things you have to look at. Right? Now remember, computer is a big guy, CPU is a smaller guy, ALU is a smaller guy. Now there's even smaller guys are there inside the ALU. But just tell me, inside the ALU, what are there? How do they build the ALU, arithmetic and logic unit? By using what? Now if you take that Intel processor, inside that Intel processor or AMD processor, what are there? Now you all know that your computer, your smartphones, you have processor chip. My question is, what is inside this processor chip? These are built by engineers in the Intel. What are inside this chip? Those things in the inside, they are going to do these things, doing these AND operations, doing these AND operations. And you are 1 year into the A-level ICT, right? 1 year, right? You have only one more year. So after 1 year, if you don't have the answer for that, you have to think about it. Have I ever seriously thought about these things? So I'm just reading things. I'm just memorizing. I'm just dumping things to the memory, right? I told you, memory is a useless guy, right? Memory is a Right. Sorry that I got disconnected. Can you hear me again?
Yes, sir.
Okay. Sorry, I got disconnected because I have power cut. Now I am on my mobile phone. Right. So still I didn't get the answer. And again, you are going to be sad if I give you the answer. Yeah, you have to be sad. You have to go and cry after me giving the answer. Right? Go somewhere and cry. Okay? Or you give me the answer. So because you have learned this for 1 year now, A-level ICT. Right. So now I'm going to make you sad. So these things are done by inside your ALU. There's something called logic gates. Right. So those logic gates, AND gate can do this. Right. If it is OR, you have the OR gates. You have the XOR gates. And even addition can be done by logic gates because there's something called adder. Right. Something called adder using XOR gates, etc. When the data goes through those adders, these data is getting added. And of course, if there's a remainder, that remainder will go to the feed to the next one. So now, do you agree that these arithmetic and logic operations are done by logic gates? Yes or no?
Yes, sir.
So why that answer didn't come from you? That means what happens is you learn these subjects in isolation. It's like different islands, but you don't look at the connection between that. So that is a terrible situation. So those who see the connections, they are the people who have understood the things properly. So you have to get into that mood now. Okay, right. So these things are done by the processing is done by logic gates. Okay, processing is done by logic gates. So then logic gate is a conceptual thing again. Right? Logic gate is not a physical thing. Right? Logic gate is a conceptual thing that you draw like this. And we say that when both are 1 it is when both are 1 it is 1, when this is 1 this is 0 it is 0, when this is 0 this is 1 it is 0, when this both are 0 it is 0. But if it is something like OR gate, when both are 1, when one is 1 other one is 0, still 1, 0 1 it is 1, when both are 0 only 0. These are just conceptual things, right? Conceptually, as a logic, we think we can consider there's something called AND gate, there's something called OR gate, there's something called NOT gate, there is something called XOR gate. Now, but this is a concept. In reality, how are we going to build these logic gates? How does engineers build logic gates? How does engineers build NAND gates? How does engineers build OR gates? Any answer? You must have the answer now because you learn the history of computing, right? First generation computers, second generation computers, third generation computers, fourth generation computers. So if you have learned that generations of computers, you must know how the modern computers build logic gates. What is the device, electronic device that we use?
Transistors.
Transistors, right? Transistors are used to build these logic gates. So do you have any idea if you take a say modern processor, say i5 processor or i3 processor, now we have i7 i9 also, just think about i5 processor, how many transistors do you think they have, just roughly? You're guessing. You can, is it 1,000 or 1 lakh or million or billion or trillion? How do you feel? How many transistors are there typically? Just I need a number. Your gut feeling. I don't need a precise answer. What do you think? How many transistors are there in this chip?
Maybe in millions.
Yes, more than million. Right? Say I3 number of transistors. That is why only few companies build it. You can see I3, they have roughly about 1.4 billion, right? 1.4 billion transistors. So that is why these countries are advanced countries, not like us. So we try to, right, always our task is doing small things, right? So I don't know how many people can count this also. 1.4 billion, right? So that number of transistors are there, right? And still we feel like our processor is not good enough, right? Sometimes still we feel like, just give me 1 minute, I want to transit back to my fiber connection. Okay, there will be brief interruption. Right, I hope you can again hear me. I just connected from back to the fiber, right? So therefore now you know that this processing is done by logic gates. These logic gates are built by transistors. Okay, transistors. Okay, so that is how it works. Okay, right. So now you must have a good idea about what is this computer is, right? So the computer, we take the inputs as data, we process it to information, more meaningful information, more useful information, right? And of course it is done by the CPU, but very precisely it is done by the ALU. Now all these data is first converted to set of ones and zeros, and your information is a different set of ones and zeros which we have processed to make it more useful. Our programs are going to do that. The logic we are going to write using programs, but those programs are executed. Then those instructions those data will be going through those logic gates to convert it to this. So these logic gates are going to do some AND operations, OR operations, like logic operations and arithmetic operations. Okay, and this ALU has millions of billions of transistors. These transistors are assembled to create those gates. Not just one NAND gate, we have millions of gates so that we can make it do this processing faster. Okay, right?
Excuse me, sir.
Yes.
Does it mean that when the computer generations increase, the transistors also will increase?
Yes, number of transistors are getting increased. Yes, definitely. So that is why I told you it is the I3. You have about, now let's see, how many in the I3, how many in the I5, and how many in the I7. Here you can clearly see that I3 1.4 billion, I5, this is the average value, 1.75, right? I7 pretty much the same because they have improved in some other ways, but in general, yes, number of transistors are getting increased, but now the engineers have found that there will be a limit. After certain limit, now we are very close to that limit. After certain limit, we will not be able to further increase the number of transistors, because everything has a limitation. Okay, because we can build the transistor smaller and smaller and smaller, but after sometimes the technology will not be able to, the current technology will not be able to make it even smaller. Either we have to come up with a new technology to make it smaller, or we have to go to a different technology. Right now, rather than the normal this processing technology, now the engineers are developing another technology, and you have to know about these things in the final topic. In your A-level ICT syllabus, you have a topic called new trends and future directions, right? If you have a little bit idea about that, you may be able to answer this question. What is another technology that we are now the engineers are testing to make processors? So anyone, any idea?
Artificial intelligence.
Yes, that is really good answer. Quantum mechanics. We are using quantum mechanics to create quantum computers. So when it comes to quantum computers, it is completely different thing that we are not going to use normal logic gates. So the quantum processors, they don't have these AND gates, OR gates, etc. It's a completely different technology that we are using to do the processing. right? Anyway, that is something that we will be discussing in your final topic, right? Your topic 9. Okay, right? So but in general, yes, number of transistors are getting higher, but we are pretty close to the limitation right now. Okay, but therefore, but anyway, now the computers are fairly high speed, right? So now we are okay, but the thing is, we have more and more needs in our life, right? So therefore people always looking for fast and faster things. Okay, right. Right, so now you must have that big idea about what is a computer, right? If you have that basic idea, it's very easy to build up your knowledge, right? So therefore, don't think that we have waste time. We try to understand because if you don't have a good foundation, right, everything is going to be shaky, right? After sometimes it can even collapse. So it's very important you have very solid foundation, right? So not only you must be able to answer, you must be able to defend your answers, right? You must be able to argue with others. No, this is the reason, because of this is the answer, right? Your answer is not the correct one. So that kind of a confidence you have to build up. Okay, so that when the exams are nearing, you are more happy, you are more confident, right? You can just relax more and more. Okay, right. So now this is how you look at the computer. You have the input devices, you have the output devices, you have the memory, but memory is not doing any of the processing, nothing. The entire burden of processing is done by the processor or the CPU, right? And the CPU you can subdivide it into 3, that is ALU, control unit, and the registries. And of course you can have the secondary storage, right? Secondary storage, always data first come to the memory, it is processed and written back to the memory and rewrite to the output. And then what is the purpose of secondary storage? If you want to permanently store data, and also your programs are also here. Okay, programs are also here. So this is what is known as the von Neumann architecture, right? So remember in your syllabus they have mentioned very clearly, they have mentioned at the end of your topic 2, students must be able to explain what is this von Neumann architecture. Right, von Neumann architecture, the stored program control concepts. Anyway, we are going to take that seriously next time, right? Right. So input devices are there, memory is there, processor is there, output is there, secondary storage is there, and of course, if you want, you can even draw backup for ternary storage. Ternary, that means if you have a CD, if you have pen drive, so we want to take backup of these things so that we can later restore in case of there's a crash in my secondary storage, or if you want to bring it to some other computer, so there's a ternary storage as well, right? And also we can add another component here, that is your ROM, right? Read only memory. So read only memory is mostly we are reading, but now we write also. So that is where you have the so what is the purpose of having ROM? If someone asks, because at the end of this topic you must know what is ROM is also. What is the purpose of ROM? Just one word, or maybe just very simple answer. Okay, right. So what is the purpose of input devices?
To input data.
Yes, input data. What is the purpose of output devices?
To receive the data.
Yes, to receive the data. Are you sure? My question is, yes,
the data.
output the data.
It's a
Output information. sir.
Output information. If you take data and give out data, who is going to use this computer, right? So input data, input devices, output the information, output devices, right? So you have to be very precise. Okay, right? So then what is the purpose of processor?
It processes the data into information.
Yes, it processes the data into information. But if you want, you can do one more sentence to that, because you can see it has ALU and control unit also. It processes the data and does the overall control, right? It processes the data into information and does the overall control of the system as well. Okay, right? So then what is the purpose of, now don't rush to answer, first think about it. Okay, what is the purpose of memory or RAM or primary memory?
To store data.
That is the answer I get from almost 100% of the students. To store data. That answer is not correct. That answer, if I ask that question in the A-level paper, if you answer that, if there are 5 marks, I will give you only 2 marks. That means everyone is going to get that 2 marks. I don't know whether any student will get more than 2 marks.
So it provides instructions.
Provide the instructions. I think your answer is somewhat closer. So if you take your memory, now look at my, now I have 8 GB of memory. Okay, I have
So it's a space to process.
space to process. No, processing is done here, and registries are there to keep that data. Now if you look at my memory performance, you can see it, I have 8 GB, currently 6.1 GB is used. Do you think that this 6.1 GB contains data? What do you think? What does this 6.1 GB contains? All the data?
No, sir.
Then what does this 6.1 GB is using? Used for what?
Instructions, sir.
Yes, right. The moment you boot your computer, already you will say at least 3 GB is already using. So what is that 3 GB? Mostly your operating system. Then when you open, like for example, when I open this browser, now you can see all of a sudden this memory goes up. So is it data? No, this browser is not hasn't loaded any web page, right? So that my Chrome software is loaded to the memory, right? So now again you can see that out of my memory 90% is program, right? It is programs that has been loaded. But when someone asks what is the use of memory, unfortunately you guys tells it is keeping data, but it is keeping maybe 5% of the memory is keeping data, 90% of the memory is keeping the programs. Then why you are telling the memory is keeping data? Memory is keeping both programs and data. Again, not all the programs. For example, in my computer I have Photoshop installed, right? I have Photoshop installed, I have Access installed, but Access is not currently in the memory. So therefore you have to be very precise. What is the purpose of memory? The memory keep the currently running program segments and relevant data, right? I have so many Word documents, but currently this document is in the memory. That is why I can scroll it. So therefore what is the proper answer? The memory keeps the currently running program, not the entire program, also program segments, relevant program segments and relevant data, right? So try to give a perfect answer, then you don't have to worry, right? So then you don't have to worry, you can be proud of yourself, right? So that is the purpose of memory. Now again think about it and answer. What is the purpose of secondary storage? That is your hard disk, or if you have SSD drive, SSD drive. What is the purpose of this secondary storage? This is the primary storage or the main memory.
It stores information permanently.
Is it only information?
Data and information.
Is it only data and information?
Instructions.
Yes. If I take my Z drive, mostly it is occupied by my operating system. So with this Windows folder, it's not data, it's my operating system, right? You can see, right? Still it's more than 5 GB, right? It's 8, right? So this gigabyte of operating system. Now if you go to the rest of the stuff is most program files. They are not data, they are programs. So your secondary storage keep permanently store programs and your data and instruction. Both basically your data and maybe data and information, because you can keep this kind of documents which are not processed data, and also you can have this kind of PDF which is processed data. You just keep it for later use. So if you are really precise about your answers, your computer, your secondary storage is used to permanently store programs and your data or instructions, right? So that is your answer, right? Now we discuss how many components: input, output, processor, memory, secondary storage. Of course, ternary storage is to offline and backup those things. So usually we don't always keep it connect with that. Whenever we need, we take the backup. Later you can restore it, right? So then the final one is the ROM, right? Because let's discuss the ROM and finish it, because otherwise we are just keeping it. What is the purpose of ROM? Now if you have a component and if you don't know the purpose, that is a really bad thing, right? You must know what is the purpose of heart, what is the purpose of lungs, what is the purpose of brain, what is the purpose of your kidney, what is the purpose of your stomach, right? So similarly, if you are doing ICT and if you don't know what is the purpose of ROM, you are in deep trouble, right? People are going to laugh at you. You are doing ICT and you don't know what is the purpose of this device, right? What is the purpose of ROM? If
So
it
it
is
stores booting instructions.
okay, yeah, so that is a reasonably good answer, right? But that is only one part of it. So right, so basically it is one of the tasks of ROM, right? Boot up the system. So yeah, but I accept that as answer. So your ROM contains
All the instructions.
Sorry,
It contains all the instructions.
which instructions?
Computer instructions.
Then why do you need programs if everything is in the ROM? So your programs are in your secondary storage. My Photoshop is here. So some instructions are also there, but not all the instruction, right? Most of the instructions are in your secondary storage, that is your programs and your operating system. Okay, here also it contains bit of instructions as well, right? So in general we can say your ROM contains firmware, right? Your ROM contains what? Firmware, right? Now you must be able to look at the computer in another way now. So this is actually, we look at the computer's hardware, right? This is how you look at the computer's hardware: your keyboard, mouse, your printer, monitor, your processor chip, your memory chips, your ROM chip, your hard disk or SSD, your pen drive. So whatever, actually this diagram is all about the hardware, but computer is not only hardware, right? How do you look at the computer? How many components are there in a computer? If you want to look at the information or the computer system, what are the components of a computer system? Hardware is just one of it.
System software.
What else?
firmware, liveware.
Okay, so can you put it into a diagram? You have the hardware. So that is basically what we draw here. Hardware. Then on top of hardware you have firmware. That is your ROM contains your firmware. Then you have the software. Software we can subdivide it into system software and application software. So many application softwares, right? Your word processors, Photoshop, right? Application software. Then of course the users also we can just call them, because we always use where we call them liveware. So they can interact with this, and of course they can interact with the system software as well, right? So what is the purpose of hardware? That is ultimately it is the hardware that we use to input data, store data, process data, because your data is in your hard disk, your SSD, right? Your processing is done by your ultimately it is hardware that does the things, right? Your processing is done by the your transistors. Okay. Then you have the system software and the application software. This one is pretty much the operating system and other system utilities. This is where your application software, whether it's order processing system, inventory management system, etc., billing system if it is office, or if you are using it for your personal things, maybe WhatsApp, Viber, your browsers, etc. Okay, right. So this is how you look at computer as a whole, But if you dig into the hardware part, this is how you look at it. So that is how now you must know the connection between this diagram and that diagram, right? So in this diagram the hardware part is this, right? Hardware part is this. Now we are going to learn about this operating system as a separate topic. Now you must know the big picture, right? So that is why you have another topic in your syllabus. It says operating system, right? Fundamental, so compute operating system. So there we will be learning about one of the main system software. Then these application softwares we will be discussing in your programming subject, how to develop these application software, right? And of course including the database. Then what is the process of developing those software, what are the best practices engineers use, right? So that is what we are going to learn overall during your syllabus. Okay, right? So it is a big syllabus, but those who understand the big picture, interconnections, especially the big picture, you must not fear of looking at this big picture, right? Some people fear of looking at the big picture. They just hide behind these small topics. Don't do that. Okay, just have courage to look at it. Okay, right. So we are going to stop at this point, how it goes. Okay, right.